Okay, this hangout is really on. It's really online. It's really live. What is this, Lady Ada?
This is. No, I'm not going to pinch you. Don't worry.
Not again.
Yes,
not
again.
Not the pinchers.
The pinchers. This is like a fun toy. Hey everybody, welcome to a totally consensual, non-pinchy show and tell, where we're gonna have a good time with all sorts of people from around the world showing off their cool projects, whether they be 3D printed pinchers or electronic tweezers or computer software, websites, hacking, making, sewing, any kind of fun stuff.
Yeah.
And we're gonna have a really good time for the next half hour. Gonna have some Adafruit peeps show up what they're up to, and then other people take a few minutes when we call on you. We gotta get out of here at 7:55. Right. Take it away, Scott.
Hello. This doesn't really have to do with what I'm doing for Adafruit officially, but the toaster oven. I got some large purple boards from our purple board providers, Osh Park, and I assembled it. So this is the front panel of my toaster oven. It's got a SAMD 51 on it in the TQFP package, which is interesting. Most SAMD 21s are all QFN. I plugged it in, powered it up with my power supply, and it was it didn't like short out, which was good.
Yay!
But it took a lot more power than I expected, like 400 milliamps. And so I've still got to debug why it's taking that much. And I think it was getting a little warm. So it's not perfect. I did have to. The other big question was, this is the front panel. This is what the front panel of the toaster oven is. The question was, will it actually sit down? Like there's this big question of mechanical fit. And it was really close. I filed down a few of the holes with some files I had. The cat is tearing paper apart because she hates it when I talk.
No talking, even.
Awkward.
Yeah.
More petting.
Oh, right.
Less talking.
I don't think that paper is important. It might be tax related. We'll see.
Tax code change. Cats can file.
Anyway, so I then I filed some holes down and it fit, which is great.
Okay, grab that cat. Okay, that's what a cat wanted.
This is Vin.
Hey, Vin.
She likes to tear paper up when she's frustrated.
Me too.
Or when I'm talking. She'll be sleeping on my lap and I'll talk in a meeting and she'll be like, oh, I hate this.
Well, she's got gigantic ears. If you had ears that big, you'd probably...
Yeah.
It's true. They can like move them away from the offending noise though.
Yeah.
That is pretty talented. Okay, well,
No
thanks
excuses.
for the pie oven update.
Yeah, well, I'll get back to it
not
at some
right
point.
yet.
It's true. It's very true.
Okay, cool. Thanks for the update. All right, next up, Phil B. What's going on in Phil B land?
Hello there. Well, you know, we did this project with the accelerometer and LEDs, making like a little sand physics toy.
Yeah.
And I've been playing around with the code, turning it into a C++ library. And I added the ability to put little obstacles in the path for it to dribble around. So we could do like a hourglass type thing. But hey, as long as it's a C++ library, that will, you know, that can be ported to other things. And I got this part I was supposed to be testing. And so I ported that code to the Raspberry Pi and have it running on a really big RGB LED matrix.
That's so much fun.
Yeah, so that's I think 1,200 particles in there. Has no problem handling that. But the C++ library, it is already on GitHub. GitHub Adafruit / Adafruit. I don't remember the name of it.
Pixel Dust.
Pixel Dust.
Pixel Dust. Thank you. Don't get old. It's terrible. But the C++ library is there, and I will add some Pi code to that soon. But as it is, there's already the Arduino example in there. So that's the plan.
Super fun.
These pixels are like the days of our lives.
All right, thanks for your time.
Yep. All right, next up, Don Pedro.
Hey guys, so this week's project, super practical 3D printing. It is a little mount for our cable charger for our car. So super simple, it just snaps onto the shelving that we have all around. So we couldn't make like one so we could bolt it into the wall. So super simple little design that has a little nub in here that actually holds on the little indentations that are on the Tesla chargers for the car. So super simple, it just grabs on like that. It acts as a counterbalance, and then this little wall right here prevents it from coming out. And then this little clip that Noah designed to snap onto the side of the shelves holds all the weight on it. And then we also made one for the big gauged wires that also attach to there. So simple design, all editable lines, so you can adjust these to whatever gauge wire you have for doing cable management. And the guide is really just showing how to make those into user parameters. So simple. And I think that's pretty much it.
And this plugs into your car that doesn't take gas.
Yes, so I think we put the reservation in for the Tesla Model 3, I think like 3 years ago, and today was delivery day, and you can see it kind of back there. Turn the lights on.
Yeah.
That's cool.
Turns out they come in Adafruit Black.
Yeah, you can kind of see it back there.
Yeah.
That's nice. Oh.
Yay.
Hey, hello.
All right.
Hello, robot.
There you go. Hey, there it is. But super fun to drive. Of course, no more gas. We traded in our Jeep for it, so no more gas anymore. Yeah.
Cool.
And of course, we had to do some 3D printed projects for it.
Yeah, like obviously.
Duh.
It's cool. I through the eyes of your kid, Peter, I think it's neat that there is a world where you can make anything and cars don't have gas. Like that's an amazing, like every screen is a touch screen. It's not like a TV like when we were all growing up. Like everything's a little different. Not what the science fiction authors predicted, but not too bad.
Hopefully, definitely for the better, I hope.
Yeah, I think so. Well, if not, we'll just print something. Okay.
Thanks, guys. Thanks.
All right. Thanks so much. We'll be playing some videos that you gave us tonight on Ask an Engineer. Okay.
Thank you.
JP.
Hey, everybody. So first off, can you hear me?
Yeah.
Trying a new thing. Okay, good. So my project that I worked on last week on my live stream, I want to show off, and it's based on this little sequencer and synthesizer called a pocket operator. So normally you get to use these little tiny calculator buttons to play, and then you can program sequences in, and you can string them together. So these are a ton of fun. I love them, but I wanted to build one that you could perform with a little more easily, like finger drumming and that sort of stuff. So I'm going to switch cameras over to my overhead on the workbench and show you the one that I've been building. All right, so that there is a little wooden drawing or painting briefcase for carrying around your paints and canvases and stuff. And I've built into it the pocket operator. This is the arcade one, and then a bazillion arcade buttons. These are all wired to the existing buttons, which are not a matrix, actually. Every one of these buttons has its own separate input and ground, or output and ground. And so I've replicated every button over here and the knobs over here, but I can still use the display and watch the sequencer lights on there. So here's a sequence that I'll just hit play that I programmed. And I've also added a big speaker here. You turn it down. And then I can play on top of that. And run different effects. Bring in a chorus.
It's like the Williamsburg music scene in a box.
So
Nice.
that's the pocket operator arcade briefcase. And since you probably want to see behind the scenes here, it's actually not mounted in here at all, other than when it's closed, it doesn't move around. And I made the fit pretty tight on the acrylic here. And that's the mess of wiring that I've got going on back here. So I have all these arcade buttons wired in series for the ground. And then each of the buttons goes to this little perma-proto board, which then goes to all those buttons around the front. And what I think I'm going to be working on tomorrow on the live stream is this edition of, I'm now powering it from a Feather and a LiPo. Normally this is powered by two AA or AAA alkaline batteries, but I've stepped down the output here to 3 volts from the 3.3 using a diode. And now, since this is in here, I might try to get up to some interesting shenanigans with NeoPixels. So that's the plan for tomorrow, and that is all I got for today.
That's pretty sweet.
A lot of people don't know this is the original briefcase from Pulp Fiction, and this is what Marcella Wallace was trying to get back.
Oh my God, I've ruined that. No one was supposed to know.
I know. I'm sorry I ruined Pulp Fiction for everyone.
JP's
All right.
game. No, okay.
Back in the box.
That
All right. JMK.
Hey, you're muted.
Can you hear me?
Yeah, you sound great.
So I've been working for a while. So JMK 1.8, 1.8.1, they've been released. But after that, and originally I wanted to have JMQS GUI ready for the launch of 1.8, but I ended up having to delay it just because problems with getting PyQt on all things that support it, differences in how the graphical interface works on each OS, and a bunch of updates for PyQt that made me do a bunch of annoying stuff. So right now I am just going to show a sneak peek of some buttons and things, how some switches and buttons and UI elements UI elements that are default if you don't theme your own application. If you make it for JMK GUI, for JMK OG, this is GUI. So this is how they'll look. I'm just launching it.
You want to share your screen?
Yep. It doesn't work on Vivaldi browser, which is why one time I got a bunch stuck. All right, here we are. Hide. So this is some loading indicators. This version is optimally, it says JMK Mobile up there. This is supposed to be fit on a tablet, which is why this is kind of shaped in like a Kindle Fire. Yeah. It's made to fit that kind of device. So what it is that's like a spinner, that's a checkbox, buttons, check delegate, which is like see how that's highlighting a box? That's highlighting the checkbox, switches, spinners, a giant keyboard. As I said, this is for a tablet. Close, and a bunch of cool things, radio button, radio delegate, go away keyboard, and yeah, then there's math. Like this will show off how maybe a math application would work. It doesn't work right now, but this is showing off how something would work. This is a copy when I was trying to use a different theme within one application. Don't try that. Don't try to make one application have two themes. It doesn't work. Yeah. And also, I've been working a little bit on more JMK web stuff, and actually I'm going to stop screen sharing, I think. Screen share. Stop. Yep. All right. So I've been working on JMK web stuff, and I also I found this like cloud USB Linux distro. So it has like a bunch of like stuff. So like on the go, there's just like a little USB.
Yeah. Oh yeah.
There's no case on it. It's just the circuit board. That has cloud USB Linux on it, so I can just plug it in, boot it up, and then full Dropbox, like built-in support, Google Drive links. There's a private and public folder, so somebody couldn't just take the dry boot from it and have all your info. You require a password, and then there's a public folder, which you don't have to do. And then I also, this isn't totally related, but I got this out yesterday. 3D, it's a Nintendo 3DS XL. I haven't played with it in a while, but I realized it has some good capabilities for like AR stuff. Yeah. So I might be like messing with that soon.
Cool.
They make it surprisingly easy to open its system files. There's actually a built-in function in settings where you can broadcast the SD's contents over network to a PC, which makes it really easy to hack. So perfect.
Yeah.
Yeah. So that's it. For now.
Okay. So much. Great stuff, JMK. As always, if you want a sticker, support at adafruit.com. Keep up the good work.
Yeah, PyQt. Yeah. I'm always struggling with PyQt also. Real pain.
Yeah. It's annoying because a library, sometimes you when you're trying to use PyQt and you add a Python file from within your PyQt project, all the example code online is for an external Python file to import somehow the PyQt library from the app, but you're not in the app, so you can't do that. But then it includes files for showing how the screen is showed, but I want to add that so the Python file links to the files that are, it's crazy. So yeah, I'm trying to figure out how that works.
That's totally, you're not the only one.
Yeah. Stay away from Java servlets.
Yeah, don't do
applets.
Java.
Yeah, watch out
Java's
for that.
Java's a good one.
Yeah.
Java.
All
Love
right.
it.
Next,
Thanks.
Dave. Hi, Dave. How's it going, Dave?
Hey guys, it's going pretty well. This week I have the sort of next version of my shields for playground, circuit playground. So as was shown before, I did a guide. It looks like that. Now on the back, you have a nice little proto board that has a, the flight time of flight sensor on it. I got an app on there, so the bar graph shows up how far away things are. There's also one that has a cable connection, so it's got a 2x14, so you can plug a ribbon cable in. So you have a sensor inside a piece of equipment and the circuit playground outside. And then there's also a version that is made to go onto a breadboard. It's got a DIP 14, or sorry, yeah, DIP 14 connector on the back.
That looks so cool. Nice work.
Yeah. So they turned out well. They just work nicely. I did, the previous version, I had these 10mm standoffs, and now my order of 6mm standoffs came in, and it's way better. It's sort of tighter integration, less wasted space, but just enough room inside, so hitter pins or whatever aren't touching.
Okay, Dave, you know where to get us if you want a sticker. And then here's a community project. If we were to come up with a name for these things, shields, we already know what those are. Wings, yeah, what are they? It looks like it's on a playground. It could be like one of those little spinny things that makes you dizzy and throw up.
Merry-go-round?
Could be a merry-go-round. Could be many, many things. Community ideas. Put them in Discord. What would you call a circuit playground shield?
There you go. All right.
All right. Thanks for the update, Dave.
Carson. Hello, Carson. How are you?
Hello.
Oh, Carson, you're muted.
No, I can't hear you, though.
Yeah.
No.
Well, Carson, maybe you can hang out, try to figure out the audio, and we can come back to you. And if it still doesn't work, we will do maker charades. So you'll just hold up your project, and then we'll guess what it is.
But meanwhile,
we're gonna go to Adam, and then we'll bounce back over to you, Carson.
So, hello.
Hey, Adam. How's it going?
In the shop.
Cool. I'm on Wi-Fi right now because my Ethernet link decided to die this morning. So we'll see how this goes. Anyways, so I've got the SPG30 under the SEM right now. I'm going to show a couple of photos after the decapping process. Shockingly fragile chip. I wasn't anticipating having to break two of them to get one to successfully decap, but that's what it took. So that's what we did. So this is kind of a zoomed out view of the SPG30. You guys can see my screen, right?
Yeah. It's right
Great. So we can see in the center, I've already taken the top layer off. It turned out that I was being a bit too aggressive at first, and being too aggressive resulted in a shattered piece of silicon and plastic that still had some interesting details in it. So we'll get that under the SEM at some other point. But all you have to do is there's just a little paper layer, kind of a paper layer on top. You just peel the little paper layer off, and the chip comes apart to the point where we can actually start to see the insides. That's very different than the other sensors, or any of the other environmental sensors I've decapped. I've had to actually pry a metal or plastic lid off. So this thing's built a bit differently. And while we're here, I'll cover a couple other things we did. I've been having this weird what I thought was that 90.9 megahertz noise last week. This thing is actually 60 hertz.
Oh.
What was happening is my oscilloscope was acting. Oh, I don't have a photo of it here, I don't believe. Oh, I do. My oscilloscope was acting like so much of an antenna that I couldn't actually see what was really going on. And while the amplitude of the 90 hertz noise that I saw on the oscilloscope was correct to be the problem, it wasn't actually the correct frequency. So I had to figure out some way of generating a video signal on the SEM that would allow me to watch the movement of the video signal on the scope, which is actually kind of a difficult challenge. So what I did is I found a really, really narrow sample, like narrow as in like you measure it in nanometers wide, and I scanned that under the SEM, and then I adjusted my brightness and contrast so it gave me one giant peak in the center. By giving me that peak, it allowed me to observe the wobbliness on both sides. Once I did that, I was able to correlate the wobbliness to line voltage AC and see that, yeah, this thing is oscillating at 60 hertz. The reason that was so difficult is because it's not just a straight 60 hertz. The 60 hertz is rolling in relationship to the frame generator. I run at about 31 hertz for my vertical or my horizontal scan rate, which means that the 60 hertz is rolling across it. So it made it look like a much higher frequency. Now that I found that, I've started isolating cable bundles. This giant umbilical down there is all of the interconnects between the column and the control console, including some pretty heavy gauge AC stuff. So I've been starting to pull the AC out in an effort to get rid of it. I haven't quite isolated it yet, but I'm pretty sure I'll be able to find it eventually.
Okay.
Anyways, now that we're done with a little bit of background, we can go ahead and stop sharing and look at the chip under the scope. Once I get my window up, I can see the camera. And if you see anything that's of interest while I'm zooming in on it, feel free to let me know, and I'll go ahead and focus on that part.
Yeah, and then we're going to pop over to Carson, so give yourself like a minute.
Yeah, I'll keep it like another minute or so.
Yeah.
Okay, let me get the camera a bit closer real quick. There we go. So we can see we've got that structure kind of suspended on the inside that we saw earlier, so we can go ahead and zoom in on that because it is actually really, really cool. I'll go to 200 times meg, give me some rapid, go there. A lot of using the SCM is learning how to interpret noise, such as this. So we can start to see here there's something weird going on. Now what makes the SPG30 is actually the SPG30 special is it has four metal oxide sensors on it. We can actually see those four sensors. There are these kind of clouds in here. And so that's each of these is a different chemistry, a metal oxide sensor, and is really good at detecting a different type of gas. And below that we have this kind of really interesting heater setup. So if we zoom into that heater a bit more, we can see we got elements all over, and there's a lot of different traces built into this suspended piece of silicon to really evenly heat this thing up, and then also measure the electrical properties of the metal oxide as it's exposed to different environments. So it's quite a complex sensor, and this whole thing is suspended on this grid with a surprisingly large number of interconnects going to it, as you can see. So the thing really did take quite a bit of engineering, and I'm guessing some pretty unique processes to do.
Yeah.
This whole thing's actually suspended in a hole in the silicon. The hole is maybe a 0.5 millimeter wide, but it's perfectly round. And doing a hole in silicon that big is definitely a pretty non-traditional semiconductor manufacturing process. So they really did do some unique stuff. Now, the thing I haven't been able to find yet for this chip is actually where they're doing the I2C logic, because this does have I2C built in, so you can just communicate to it as a device instead of having to do analog conversions or something like that. I suspect that you can kind of see some traces and some interesting details around the edges here, that it's actually underneath the epoxy, but I can't really confirm that until I get some red fume nitric acid out. I don't have that in my shop, but I do know where to go get it now, which is always fun.
Yay!
Yeah, red fume nitric acid is amazing.
All right.
All right, good times.
Thank you so much, Adam.
Thanks for the update. Look.
Yeah, for sure.
All right, we're gonna pop over to Carson. Carson, you want to try your mic or Maker Charades? It's Maker Charades. Okay. All right, you have a project, and the project is it's something to do with 3D printer.
It's a 3D printer.
Okay.
And
then you have a box.
It's a box
next to the 3D
next
printer.
To it. But what is it?
What could that box be?
It's maybe a Raspberry Pi computer. Looks like one.
You're
okay.
powering.
Yeah, it's a Pi.
You're powering
and it's running like Octoprint, maybe doing time lapses.
Do we get it? Do we get it? Okay.
Yeah.
So that's the first syllable is
Pi.
Okay. And this is a box.
It's a box.
And this was the prototype maybe before. Oh no, you made another one, and that looks like it has syringes in it, and it's a cardboard 3D printer.
What is going on?
I think he made a 3D printer out of a cardboard box.
Yeah.
No. Okay.
This is fun.
Okay.
Okay, so that's a totally different project, I think.
Totally different project. All right, new project. Okay. This project has something.
Has eyes. No, wait.
Those are.
They're syringes.
Is it pneumatic? Is that
Yeah,
air?
those are pneumatics.
Okay. And then
what is it doing?
When you press the thing, it does a thing.
Something should be moving, but I don't see what.
I think there's a display, and it's like there's air pressure there, and there's a certain amount of something.
Yeah.
something.
This one is.
This is a tough Maker Charades.
Wait, is that like a character inside or something?
I'm gonna see if someone can help in the chat.
Yeah, I'm confused. This is good. I finally don't know what it is.
It's a Pi controller 3D printer. Yeah, and you 3D printed cardboard now. That's not right.
Okay.
Yeah. All right. It might be a mystery.
This is a good mystery, but it's something with like the pneumatic. The syringes are pneumatic.
Oh, no, you're moving them. Oh, I see. You're telling the microcontroller to move the syringes to certain points.
But he's squeezing them.
Oh, he's squeezing them, and then the other one's doing something. We're getting
But
close.
I don't know what he's sensing. It's like sensing something.
Yeah.
Or
All right,
why
Carson.
Is it moving? I don't know.
This is a cool.
This is good. You stumped me.
Yeah, people in the chat will figure it out.
Okay.
So Carson, send a email to support today for you get a as seen on the show and tell sticker, and come back and show this again. That means you get double the stickers.
Yeah.
It's totally fine. Well played, Carson.
You're nice. You did a really good job. It's on me. I don't even know what it is, but I'm sure it's awesome. So I'd love to see it next time.
Someone said, "Oh, you could probably write what is on the cardboard box." That's no fun.
No, you gotta.
All right.
Do the words.
So we're going to do Ask an Engineer event. Thank you, Scott. Thank you, No Pedro. Thank you, JP. Thank you, JMK. Thank you, Dave. Thank you, Carson. And thank you, Adam. We're here every single week, 7:30 p.m. Eastern Standard Time. Thank you for making this the best half an hour of our lives. So we'll see you on Ask an Engineer in just a couple minutes.
Thank you, everybody.
Bye, everybody.
That was super fun.